This video is on function transformations. This is just talking about the big idea of function transformations, just to remind you what they all look like. The general forms all have a, h, and k, regardless of what type of function it is. So these are just three different ones we have. We have a quadratic, a square root, and an exponential. The thing about the function notation tells you if it is being stretched or compressed vertically, moved left or right, and moved up and down. So when you are doing any type of function, if it is in the correct notation, you can determine the transformations without looking at a graph. So the big idea is we want to be able to translate left and right and down and up. So to translate left, your h must be negative. So you'll have a negative h because that's your horizontal movement. And to translate right, you'll end up having a positive h. Now, when you're looking at the actual equation that you're given, the negative h will look positive on the inside because in order for it to be a negative h, it'll say x minus a negative h because it has to have that minus sign in there. So if you see a plus sign inside of it, you really had to get x minus a negative value to get that plus. So it looks like a positive, but it's really a negative h. Same thing with right. To go right, it looks like a negative, but it turns out to be a positive h value because it's x minus that positive h value to make it go right. To translate down and up, so we're going to do the same thing for down, you'll have to have a negative k value because your k is what moves it vertically. To move it up, you have to have a positive k value. Now, the sign on the k value is actually what it is, because if I wanted to add a negative, it would say subtract. If I wanted to add a positive, it would still say addition. So the k value, whatever it is, you're just going to keep that sign with it because that's what it is. It's the h value that's actually different. You're going to change that h value because to get that minus h, it had to be x minus a negative h, so it would look like a plus. You're also going to be stretching and compressing. This is for a vertical stretch and a vertical compress, not a horizontal. So to stretch, your absolute value of a must be greater than 1 because it has to be multiplying it to get bigger. So the y values will actually get bigger. The absolute value, because stretching and compressing doesn't go with the negative aspect of the a, so that means that it will, then if you see a negative on there, that will go to something else. To compress, which actually makes it go like flatter, your a value, your absolute value of a has to be smaller than 1, but it will still be bigger than 0. So that's kind of the same thing. The absolute value still has to be bigger than 0 no matter what because absolute value is bigger than 0. So I could have just said that a has to be smaller than 1, but bigger than 0. But then the a value can also affect the reflection vertically. The a value, again, goes to a vertical information. So vertical stretch, vertical compress, and vertically reflecting. So in order to reflect vertically, which really means you're reflecting over the x-axis, that's when your a value is negative. So if you have a negative a value, that means you're going to reflect over the x-axis. That's a vertical reflection. But you can also horizontally reflect. That means that you're going to reflect over the y-axis. That means that your graph is going to flip and face the other way. It's going to point left instead of right. This is when the x inside your symbol is negative. So you're going to have a negative x. you will have to make sure that you factor out that negative inside. It'll stay inside the symbol, but you want to make sure that you can determine your H value. Because if you have a negative X, that means that your H value also changed. So it's just easier to go ahead and to factor out the negative from the X and the H to determine your H value. So these are the big ideas, the main things that you need for function transformations. And then you can graph anything as long as you know the original parent function.